Hello pre-calculus. We're going to do direct inverse and joint variation, which should all be review from Algebra 2, and actually mostly review from Algebra 1. So direct variation can be described by y equals k times x to the n. Unless it explicitly says that you want it varying with x squared or x cubed, you can assume n is just 1, and we're just doing kx. So the k is called the constant of variation. We say that y varies directly as x to the n. Direct variation will always go through the origin. So if there's a y-intercept that's not 0, it's not direct variation. Suppose y varies directly as x, so that means y equals kx, and y is 45 when x is 2.5. Find the constant of variation, write an equation. To find the constant of variation, we just solve this, divide both sides by 2.5, and k is 18. There's our constant of variation. To write an equation, then, we say y equals 18x. This sometimes puzzles people because we go from having numbers to finding a number and then using that number but not the other ones. Remember, this is like 1 point on the line, right? 2.5 comma 45. That's 1 point on the line. And what we want to do is write the equation of the line. So since we know that it's got to go through 0, 0, we find the slope. Constant of variation and slope in a direct variation are the same thing. And just write the equation of the line, y equals 18x. Use the equation to find the value of y when x equals 4. We use the equation we just found. We plug in 4 in place of x. Plug in 4 in place of x. And we get 72. So when x is 4, y is 72. It is possible to do these in another way. If you don't need to find the constant variation, you can also do them as proportions. So if y is 45, when x is 2.5, this is y over x, then that has to be equal to any other y over x from that same direct variation. So we could say, I want to know y when x is 4. If you set this up as a proportion, you can cross multiply to solve it, and you should still get 72. And both of these should evaluate to 18. That is 45 divided by 2.5 is 18. 72 divided by 4 is 18. When an object such as a car is accelerating twice the distance it travels varies directly with the square. So they get more complicated. Let's write that out. Twice the distance d, so 2 times d, varies directly with. So I basically translate that immediately to equals k times, and then the square of the time, t. People often read right past the square and don't write it down. Here's our equation, 2d equals k times t squared. And one car accelerating for 4 minutes, that's our time, travels 1440 feet, that's our distance. So you can then solve the equation. 2880 equals 16k, k equals 180. There's our constant of variation. To write an equation, we go back to using variables for d and t. 2d equals 180 t squared. If you want to graph it, and I know it says to graph it, so I might turn this into y equals 90x squared. I'm just dividing both sides by 2. And then it's like this goes up very, very fast. Because this is a real-world problem, the negatives are irrelevant. We're only looking in quadrant 1. And when this is 1, y is 90. When x is 2, y is 270 or something. So it's a very steep graph. I'm not quite sure why we want to graph it. Okay, more interesting, use the equation to find the distance traveled by the car in 8 minutes. Go back here, so 2d equals 180, and instead of t, we put 8. 180 times 8 squared. Do 180 times 8 squared, and you get, I think, 11,520 feet, I think. Sorry, I'm kind of working backwards. Divide both sides by 2. Your final answer should be 5,760 feet. So that's definitely the right answer. So in 8 minutes, using this equation, the car will travel 5,760 feet. So this is just repeating what I said up here. If you know that y varies directly as x to the n, and you know one pair of x and y values, you can use a proportion to find the other corresponding sets, because if you divide both sides by x, you get y over x equals k. And any pair from that same variation has to be equal to k, so they both have to be equal to each other. You can always solve them that way, and that's fine. Inverse proportion. Inverse proportions, these do not go through 0, 0. Inverse proportions look like this. They're rational. You know how much you love rational functions. So they said they vary inversely with each other. That means when one goes up, the other one gets very small, gets very close to 0. And as the x value is getting really small, very close to 0, the y value is getting really, really big. That's an inverse proportion because they're doing the opposite of each other. So y varies inversely as x to the n. You can write it as, you can do it this way. I always do it this way to make it sort of consistent with direct. So a proportion can be used if you want. What you would do is you would say x to the n y from your first set of values has to equal x to the n y from your second set of values, and solve them accordingly. But I always do them using y equals k over x. So y varies inversely as x, y equals k over x. And y is 14 when x is 3. Then, first of all, what's k? K is 42. And then find x when y is 30. Usually they give us x. This time they're giving us y. That's okay, that's no problem, as long as we don't get confused. So we put in 30 for y. Oh, I'm sorry. We should rewrite our equation now. Y equals 42 over x. So we plug in 30 for y equals 42 over x. To solve this, we'd have to multiply by x first and then divide by 30. X equals 1.4. Another type of variation is joint variation, when you're varying directly with two other quantities. So, many things are like that, and basically you've got to put in both of them. It's really just like direct. The math is a little more complicated, but not really. Okay, in physics, the work W varies jointly as, so that means we can say right now, W equals K times charge Q and voltage V. So W equals K times Q times V. Find the equation of joint variation of a capacitor with a charge is K. Sorry, charge is Q, so 0.004 coulomb. And a voltage of 100, voltage is V, and we don't know K yet, performs 0.2 joules of work, so that goes over here. So what you can do is do this multiplication. So 0.20 equals K times 0.4. Divide both sides by 0.4. 0.2 divided by 0.4 is 1/2. 1/2 K. 1/2 equals K. So our equation is the work done varies with a constant variation of 1/2 jointly with Q and V. That's it. I wanted to make sure that you saw a problem like this because people get tripped up, but they're actually very straightforward. You can have both direct and inverse in the same problem. If y varies directly as x and inversely as c, that's easy. Y varies directly as and inversely as z. So you just do y equals k times x divided by z. And then plug in. So y is 3, x is 4, z is 5. Find the constant of variation first. So multiply both sides by 5. 15 equals k over 4. And divide by 4. K will be, you can say 15 over 4, or you can say 3.75. They're both correct, they're fine. And then find the value of y. You want to know y. So our equation now is 3.75x over z. So find the value of y when we already know k. X is 2, z is 8, and you can put that in the calculator if you like. Y is 0.9375. It makes it a little trickier. It's quite easy to see what happens in a direct variation. As one of them goes up, the other one goes up. In an inverse variation, one of them goes up, the other one goes down. So both of those are pretty easy to visualize. When you have more than one variable going on, if x goes up, y goes up. But if z goes up, y goes down. So having them interact with each other makes it a little more complicated to visualize. So here, if x is going down, that would make y go down. And if z is going up, that would also make y go down. So y becomes quite a bit smaller. Describe as illustrating direct variation, inverse variation, or neither. This should be really obvious. It looks like a rational equation. This is inverse variation. This, it's constant, and it's not going through 0, 0. So this is not variation at all. And this one is the simplest kind of direct variation. The reason there are no examples of joint variation on here is joint variation would require a three-dimensional graph. You'd have to have an x, let's see, you'd have to have an x, a y, and a z. And that's a lot harder to visualize, so we don't generally graph them for you. That is it. It should be quite straightforward. It really is mostly like Algebra 1. Little details of, don't forget that if it says squared, don't forget it. If it's got more than one thing, that's fine. Don't get tangled up. And you should be fine.